All right, today we are starting section 7.4. We are going to learn 2 more ways to show that triangles are similar. Today we will talk about SSS and SAS. Those of you that remember our chapter on congruence can probably guess what those stand for. The difference comes in the fact that we are no longer talking about congruent sides when we talk about similar triangles. What do sides have to be for similar triangles? Proportional. Okay, so we are no longer necessarily talking about all things being congruent. Our sides will be proportional and our angles will be congruent. All right, we'll kick it off with the side similarity theorem. As you might have guessed, and as we sort of already discussed, if the corresponding sides of 2 triangles are proportional, then the triangles are similar. Okay. They also wrote out all the proportionality statements from one triangle to the other, and the similarity statement. I would make sure you get all of that in your notes. I would also maybe underline or highlight words like proportional and similar so that we remember how this is different from triangle congruence. For example 1, we've got one triangle. We're calling it triangle A. It's triangle STU with its side lengths. And then we have triangle B over here, PQR, labeled with its side lengths. We are asked to determine if the triangles are similar, step 1. Step 2, if they are, write a similarity statement. Step 3, find the scale factor of triangle B to triangle A. Okay, this is similar to a question that was on one of your quizzes. It's got a few different parts to it. We have to address all of these parts. So, are they similar? Write a similarity statement. Find the scale factor. Those are the 3 things we have to do. All right. To determine if they are similar, since we don't have any angles marked, we're going to have to use the side theorem that we just talked about. So when we do this, if they ask for the scale factor of triangle B to triangle A, they specify how they want it, then B's sides have to go on the top and A's sides have to go on the bottom. If they specify it, we have to follow their directions. Okay, we weren't always told specifically before. So this is when we set up our ratios. What's the longest side of triangle B? 12. And we are going to compare that to the longest side of triangle A. 6. Can we reduce that? What does it become? 2/1. All right, then we have to move on. We do the next longest side of triangle B. 10 over the next longest side of triangle A. 5. Also becomes 2/1. Finally, we have to match up the shortest sides. What are those? 8 and 4, and that reduces to 2/1. So the first thing, are they similar? Yes. Okay, so the first part would be that yes, they are similar by the side. They didn't ask us to explain, but it's good to know why. So yes, they're similar by side. Step 2, since they are similar, we need to write a similarity statement. So triangle blank is congruent to triangle blank. Keon?
Triangle STU is similar, or is they congruent?
Similar.
Similar to PQR.
So ST is our shortest side, so PQ should be our shortest side. Good. STU, PQR. Good. Now I wrote it as PQR and STU because they said triangle B to triangle A. If you were to flip them for the similarity statement, I would not mark it wrong. However, when it comes to the scale factor, we have to have it in the right order. What's our scale factor? 2 over 1. If you were to flip it and put 1 over 2, it would be incorrect because they told us what order it had to be in. So our scale factor is 2 over 1. So now we've addressed all parts of that problem. Let's talk about example 2. Same process as example 1. On these, we are comparing triangle B to triangle A. Okay, so I'll always put B on top, or B comes first, which I know is not how the alphabet goes. But we're going to compare B to A. So what's the longest side of B? 12, the longest side of A. What does that reduce to? 2/3. Divide them both by 6, we get 2/3. Okay, next longest side of B is 10. We compare that to the next longest side of A. 15, that reduces to 2/3. It's looking pretty good so far. The shortest side of B is 8, and the shortest side of A is 12. That reduces to 2/3 again. So are these triangles similar?
Yeah.
Yes, they are similar by side, side, side. So we can write a similarity statement. I'm going to write it in the middle here. How do you want to name triangle B? XYZ works for me. So if we name triangle B XYZ, that is similar to triangle ABC. Very good. Finally, we have to name the scale factor of B to A. It's 2/3. We already found it. It's the same thing as this reduced ratio. So if you would like to just write SF for scale factor, you can. That's fine. 2/3. Same process on number 3. Longest side of B is 15 over longest side of A. 13. Is that going to reduce? No. Okay. So let's just leave that alone for a minute. We'll think about that. What about the next longest side? 12 compared to 12 compared to 12. Okay. What does that reduce to? 1, or 1 over 1. All right, what about the next one? 9 compared to 5. Is that going to reduce? No. So do we think these two triangles are similar? No. Based on the information that we were given, these triangles are not similar. They sure look similar, right? Okay, but just because they look similar, that's not enough information. So we would just say not similar. The sides are not all in the same proportion. The side angle side similarity theorem is a lot of words because it talks about how we need one pair of congruent angles and then 2 pairs of proportional sides. But remember, when we do side, angle, side, order matters. So the angle has to be included in between the sides that are proportional. Again, we don't really have a way to mark the sides being proportional. They do tell us that angle X is congruent to angle M, so that is something that we could mark in the diagram. And then notice that they talk about sides PM over ZX. So PM is here, ZX is here. And then they set that equal to or proportional to MN, over there, over XY. So the angle that they're talking about is in between the sides that they are talking about. Therefore, we know the two triangles are similar. All right, on example 4, determining whether the triangles are similar. If they are, write a similarity statement. So notice in these directions, they don't go on and on about asking for a scale factor and all that. Just, are they similar? If yes, write your similarity statement. So if we are trying to implement side, angle, side, what's the easy thing to look for? The angles. Do we have a pair of congruent angles?
Yes.
We sure do, so that's good. We can kind of check that off our checklist. So then we have to look at the sides around those angles and decide if they are not congruent, proportional. Okay, they did not give us an order to go in this time, which is nice. So we can go whatever order you want. What's the longest side we're given of ABC? 6. And that's going to match up with what side from the other one? Can we reduce that? What does it reduce to? 3/5. Well, that's awfully nice, because what's the other side length from triangle ABC? 3. And what's the other side from DEF? 5. So are those proportional?
Yes.
Yes. So since they are proportional sides and the included angle is congruent, are they similar? They sure are. So we could say similar by side, angle, side. Ooh. Similar by SAS. Then we just need our congruence, not congruent, similarity statement. So triangle ABC is similar to triangle DEF. Good. So it's nice when it goes in alphabetical order for us. However, it isn't always going to work that way. Questions about example 4?
You don't have to write the scale factor.
Nope, they didn't ask for it, so we don't have to write it.